Figure 1 shows a sketch of part of the curve with the equation y equals 6 over e to the x plus 2, where x is a real number. The finite region R, shown shaded in figure 1, is bounded by the curve, the y-axis, the x-axis, and the line x equals 1. The table below shows the corresponding values of x and y for y equals 6 over e to the x plus 2. Part A, complete the table above, giving the missing value of y to 5 decimal places. So all I'm going to do here is substitute the 0.2 into the function here. So on my calculator I'm typing in 6 divided by e to the power 0.2 plus 2, and to 5 decimal places I get 1.86254. Part B. Use the trapezium rule with all of the values in the table to find an estimate for the area of R. So the trapezium rule is half h, the first number plus the last number plus 2 lots of everything in between. So in this case we've got half of the height. What's it going up in each time? We can see it's going up in 0.2s. The width of each strip here is going to be 0.2. The first number is 2, the last number is 27165. This is the first number, this is the last number. Then we're going to have 2 lots of everything in between. So plus 2 lots of the 1.86254 plus 1.71830 plus 1.56981 plus 1.41994. And if I substitute that into my calculator, I get 1.6413. Part C. Use the substitution u equals e to the power x to show that the area can be given with that formula. So, as always, when we do, let's start with the integral that we would use to get to the area. We would be integrating 6 over e to the power x plus 2 with respect to x, and our limits are 0 and 1. So that's the usual integral we would do to get that area. Now let's do the substitution technique to show that it's going to be given by that. So we take my substitution, u equals e to the power x, and differentiate that. So du by dx is equal to e to the power x. Now make the dx the subject, so move this up here and move this down there. I find that the dx can be replaced with du over e to the power x. So this is going to get replaced with this. Now let's consider the limits. So when x equals 0, u equals e to the power 0, which is 1. The upper limit, when x equals 1, u equals e to the power 1, which is e. Right, let's take our integral then and make all of these substitutions. So like I said, the lower limit is 1, the upper limit is e. We've got 6 over, now the e to the power x in the u world, e to the power x in the u world is just u. The 2 remains as being 2, and the dx has been replaced with a du over the e to the power x, which we know is u in in the u world. This then just simplifies nicely to be 6 over u times u plus 2 du. And that's what we needed to show for part C. Part D. Hence, use calculus to find the exact area of R. So now we actually need to do this integral. So we are wanting to do the integral of 6 over u plus 2 du between the limits of 1 and e. Now, in order to integrate this, I need to replace this with partial fractions. I need to split this up into its separate fractions. So let's do a bit of rough working out on this. Let's call 6 over u plus 2 is equal to a over u plus b over u plus 2. We can then say that 6 would need to equal a times u plus 2 plus b times u. Let u equal 0 to make this second term here become 0 so we don't have to worry about it. That way we just get left with 6 equals a times 0 plus 2, which is 2. So therefore a is 3. Now to work out b. So if we now let u equals minus 2, that's good because that's going to make this term become 0. And we will just get 6 equals b times minus 2. So b is minus 3. So this is the integral that I'm actually going to do. I'm actually going to do the integral of 3 over u minus 3 over u plus 2. Right, 3 over u integrates to be 3 ln u, and the 3 over u plus 2 will integrate to be 3 ln u plus 2. Now to substitute the limits in, we'll get 3 ln e minus 3 ln of e plus 2 minus 3 ln 1 minus 3 ln 3. Ln e is just 1, so multiplied by the 3 is 3, minus 3 ln e plus 2, there's not much I can do with that, minus, right, in this second bracket, ln 1 is just 0, so that's going to disappear, and I'll just get the minus 3 ln 3, which I can do a little bit more simplification. The 2 minuses will become a plus, and it doesn't say how I need to leave my answer, so I could just leave my answer like that if I wished, or I could combine those logarithms together. So if I wrote this as, just swapping them around to make it a bit more obvious about how to see the logarithms. I've got one logarithm subtract another one, where they've both got a coefficient of 3. So because of that, I can use the division law. can write it as 3 ln 3 over e plus 2. And yeah, I think that's probably as simple as I could write that.